Let's investigate horizontal transformation with another kind of function. The question here is, identify the parent function, write the equation of transform function g of x, and how are the points in the two graphs related. Purposely, I have kept these questions common for all so that your concentration is more on solving the problem rather than again and again reading the same question, right? So whenever I want to change the question, I will rewrite or I'll add on to what I've already written. So let's investigate this particular graph. What do you think this graph is about? F of x is an absolute function here, right? This is f of x, right? It is always positive, symmetric about y-axis, straight lines. So two lines on this coordinate y equals to x, here y equals to x is flipped. It becomes minus x. And so our function here, f of x, is equals to absolute x, which is also defined as, it's not a bad idea to review it, right? It is always equals to x if x is greater than or equal to 0, but it is minus of x if x is less than 0, right? So the line which could have been like this now gets reflected, and that's how you see it. So this is your function f of x. Now g of x is the transform function. Now, what kind of transformation do you see? If you compare the points, like this point is on the original function, let me take a colored pen. So what do we see? We see, let's compare. This point, it comes down. Do you see that? It comes down. This point comes down. So every point from f of x is kind of vertically coming down as if you are pushing it downwards, right? So we call like that. This is one way of looking at it. So we could see this as a vertical compression. Do you see? We can see this as a vertical compression, correct? Now that's one way of looking into it. Now, since we are talking about horizontal transformation, let's have another look at this graph. Well, what I'm trying to hint at is that you could write this equation even as vertically compressed graph, correct? So that will be your answer. So your answer, which I am going to add here, is take vertical compression as transformation, right? And then solve the question. That means then g of x will change a bit, right? So that is your part. But what I'm answering is taking it as a horizontal stretch, right? So that is what I want to highlight here. Simple example, but reveals you so much. So what I'll do now here is I will see it from a different point of view altogether. And my view now is that I'm trying to see it like this. Take this point, and this point actually pushes it outwards. Do you see that? Take this point, it pushes it outward. So this outward movement is something which I am calling as horizontal stretch. Do you see that part? This outward movement is my horizontal stretch, just pushing it outside. So I say, well, my transformation here is, now let me write down that transformation which I'm looking at, horizontal stretch. So the transformation is horizontal stretch. Now by what factor? By what factor? That is a good question. So for that, let me compare the respective points. Correct? So what I will do now is write down the points for f of x and then write down the points for g of x, and from there I should get my answer, right? So let me write down points on f of x. The good points are 0, 0 and then 1, 1, correct? Oops, 1, 1 and 2, 2. So let me write down points straight away. 3, 3. Likewise, these are my points on this side. Let me analyze this side. Since we know this graph is symmetric about y-axis, so whatever we do on the right side will also be true for the left side. Okay? So I'm taking 1/2 of it. So for even functions, that's a huge advantage. You can do one side and apply the same thing to the other, right? Now let me write down g of x points. So g of x points, we see, let's go horizontally. So when you go horizontally, starting with origin, origin remains, so the vertex, it remains at the origin itself, so that particular corner of your absolute function. And then I have a point here which is kind of 1.5, right? So at y equals to 1, I get 1.5. I get 1.5 and y value is 1 here. Now this point is actually 3, right? So this point is 3 and y value is 2. And then next point is, so for 3, what do I have? For 3, I have 4.5, or I can't really read it, right? So, but anyway, it is kind of stretched to the right side, and it looks like 4.5 to me. So I'll write 4.5 and keep it as 3, right? So at 3, it is not 5, I know 5 is here, so it's kind of in between. So I'm taking it as 4.5, the x value. Now, if we compare these things, what do we find? If we compare these things, we find that the y values are same. Do you see that? So nothing is happening vertically. So when you write your transform function, then outside things are not affecting it. Only inside function is changing. So that's one thing which we have already found. Now inside, what is happening? 0 multiplied by any number will give you 0. 1 multiplied by 1.5 will give you 1.5, right? So what is 1.5? 1.5 is 3 over 2, right? Similarly, 2 times 1.5 is 3, and 3 times 1.5 is 4.5. So the sequence works. So what we notice here is that if I have a coordinate point xy on f of x, then it changes to 1.5, or I can write that as 3 over 2 times x to y. That is 1.5 to x. So that means there is k value is 2 over 3 that gives you, right? We have to flip it and then write for g of x. And now we can write down our transform function. So it is 2 over 3. You have to write reverse of this, 1 over k, that is, right, of x. So that becomes our transfer function g of x, right? So that is how you can get transfer function. Since the vertex remain, there is no translation left, right, or up and down. So there's all those things are 0, right? Since the y values are not changing, vertical stretch compression is also not there. So nothing there. The only change which we notice here is horizontal stretch, and that too by a factor of, we'll say by factor of 3 over 2. So you have to flip it and write. And of course 3 over 2 is 1.5, and that is what we notice, correct? Once you write on the equation, it's a good idea to plug in points and check. So if you plug 3 here, so if I write x as 3, 3 and 3 will cancel, you get 2. Perfect. 0 gives you 0, 1.5 will give you 1, correct? So you can just check. 1.5 times 2 is 3, and 3 divided by 3 is 1, correct? So you get your equation. So that is how you can write down equation of a transformed function. Now let's go back to our question. Identify parent function is an absolute function. Write the equation of transformed function. It is absolute 2 over 3x. And how are the points in the two graphs related? That is the relation of the 2 points, right? So these are our respective answers. Okay? So after you answer, go back to the question, read it. Did you do all the parts? Well, I have added one for you, which is take vertical compression as the transformation. Now imagine it was not really horizontally you're looking at as a vertical compression. In that case, you need to write down what should be the equation of this function. Okay, thank you.